Okay, good morning. Welcome to
FamilyMath number 79.
FamilyMath number 79. So last night I was looking through this new awesome book I got. Can you hold it up? It's called Here's Looking at Euclid, or Here's Looking at Euclid. Do you guys know why that's a funny joke? No, because there's a famous line that says, "Here's looking at you, kid." So this book is called Here's Looking at Euclid. And I learned about something called the what I think is called the Recaman sequence. I'm not exactly sure how to pronounce it. It was discovered by Bernardo Recaman Santos, who's a Colombian mathematician. So it's really cool. It's kind of like do you remember that sequence that we did where nobody knew if it ever stopped?
Yeah.
It was called the Collatz conjecture.
Yeah.
Remember we talked about that? So this is kind of like that. So what you do in the Recaman sequence, and we're gonna make a few terms of it, is you start at 0. And we're going to call that the 0th term. So I'll just write that in here, 0. And to get the next term, what you do is, to get the next term, which will be the nth term, like n will be 1, 2, 3, 4, 5, you either subtract n, that's what you're supposed to do first, but you don't subtract n if you get a number less than 0, or if you got a number that you already had. And if that's the case, you get a number less than 0 or you get a number you already had, you add n instead. Okay?
Yep.
So let's try to do a few and see what happens.
So for
0 for 1, so we should need to subtract 1. But what do we get when we do 0 minus 1?
It's minus 1.
Okay, so is that legal?
No.
So what do we have to do?
Add.
So what's 0 plus 1?
It's 1.
Good job! Alright, now for 2. Now we have to do what?
Well, if we subtract n.
If we subtract 2, what do we get? 1 minus 2 is?
It's minus 1 still.
Shoot, so is that legal?
No, you have to add it again.
So what's 1 plus 2 is?
3.
3, good job. Alright, now off to 3. What are we supposed to do first?
If we subtract n.
Okay, so what does subtract n mean?
3 minus 2. I mean, 2 minus 3. Well,
What number do we have right now?
we have 3.
3, and what's our n?
Minus 3, so we get 0. But n, the number we're working on is 3.
Okay, so we're at 3. The number we have is 3, and the n is 3. So what do we need to do?
We need to subtract 3. Well, yeah.
From what?
From this 3.
Okay.
So, we get 0, but that's a number we already had.
Okay, so what do we have to do?
Add.
Okay,
6.
so we're at 6. Now what do we have to do next? What about here?
We have to subtract 4 from 6.
We have to subtract 4 from 6. Very good.
We get 2.
What is 6 minus 4?
Is 2.
2. All right. Do we have it?
No.
Is it less than 0?
Yeah. I mean, no.
All right. So, hey, we can do that. Great. Okay. Now what?
Now 5. Subtract.
Can we subtract 5 from 2?
No.
What would we get if we did? 2 minus 5 is?
It's minus 3.
Minus 3. So does that work?
No, we have to add it.
And we get?
We get 7.
Okay. What's next?
Well, if we subtract 6 from 7, we get 1.
But that's positive.
Yeah. Yeah, but we already have it.
Oh, shoot. So what do we have to do?
We have to add 6. So 13. 6 is 13.
13. Okay. Now off to number 7.
Number 7. We would get 6, but we already have it.
We already have it. Oh, shoot.
So 19. So we have to add
13 plus 7 is?
Is 20.
20. Very good. Okay. 20. Now what about here? What about next? Now we can start going a little faster. What do we do with this?
It's 20 minus 8. So 20 minus 8 is 12.
12. Good.
We didn't get that.
We can get that. Okay, now you do this one.
12 minus 9 is 3. So we already have it, so we have to add it. We get 20 again. But we already have that.
Well, what's 12 plus 9?
12 plus 9, that 21.
21. Very good. 12 plus 9 is 21. Okay. What do we do here?
We add. If we subtract, then we get 11.
Do we have 11?
No.
No. Okay, so we get 11. All right, what do we do here with this 11? You tell me.
Well, 11 minus 11 is 0. We already have it, so we get 22.
Okay. What about here?
22 minus 12 that would be 10. 10, and we don't have it.
All right, so there we go. So we did the term up to n equals 12. So we did 13 terms, but the first term is the 0 term. So here we go. 1, 3, 6, 2, 7, 13, 20, 12, 21, 11, 22, 10. And it keeps going. You can always just keep going, right?
Yeah.
And so the neat thing about this, and this is something that no one has ever solved. Nobody knows. The question is, what do you think the interesting question about this sequence would be?
Probably, does it ever end?
Well, okay, good. Will it ever end? Can we always go to the next step?
Probably, you always could.
Yeah, probably you could. In fact, we could go to the next step here if you wanted. Wherever we are, now we just go up to 13. So what do we do with when we're at 10 and our next number is 13?
Well, 13 minus 10.
We already have 3.
And it's not 13 minus
10
10.
minus 13.
10 minus 13,
That's
which is
negative.
negative.
So we add them. 10 plus 23.
23. So we can always. So does the sequence ever end? The answer is no, because we can always go to the next one. So what do you think another question would be about this list of numbers? 0, 1, 3, 6, 2, 7, 13, 20, 21.
Well, is there a pattern?
Is there a pattern? That's one question. What's another question we might want to ask?
Well, it's going to extend for infinity.
It's going to be infinitely long. So one possibly interesting question is, do we get every number? 1, we have a 1. We have a 0, 1, 2, 3. Oh, we don't have a 4.
Yet.
Yeah.
I wonder if we get we don't have a 5, but we do have a 6, a 7. We don't have an 8 or a 9, but we have 10, 11, 12, 13.
We don't have a 14.
We don't have a 14 yet. So maybe if we keep going, do you think we would get every number? That's one question, and nobody knows, by the way. Like our next one here is going to be 23 minus 14. That would be 9, right?
Yeah.
And we don't have it. Oh, hey, we just got our 9.
Awesome.
Awesome. So that's pretty neat, right?
Yeah.
So it's such a simple thing we can write on the board, and it just involves doing a little bit of arithmetic. We get a sequence that goes on forever, and nobody knows if you get all the right numbers. All the right numbers. If you get all the numbers, that's pretty awesome, right?
Yeah.
Cool.
When you want to investigate this a little more?
Yeah.
Yeah? Okay, all right. Well, we'll stop our video now, but we can play with this a little more once we turn the video off.